Can you all see my screen? Chem has 12 chapters. And this acids, bases, and salts is chapter 7. Let me explain important things that you need to know about each of these things, okay? What should I know about an acid for me to say I'm good? Okay? What should I really, really know about bases for me to say I'm good? Can you hear me? Number one, you must know these general properties of acids that we did and their reactions. And their reactions with acids were easy because we know that the hydrogen was remaining and everything else was going. So you're going to need to know the reactions. And then you're going to need to know a few more things that I'm going to quickly highlight in this lesson that you may be asked. Some of them are 2-mark questions. Some of them they have more marks, but we just want to quickly understand and at the end know one more thing, okay? One more thing that I'm going to need you to know at the end, which is going to be how to separate oxides, because I'm sure all of you remember from the lesson we did yesterday. Let me go to the board. We are doing chapter 7, acid, bases, and salts. And there are important things that I'm going to need you to know, okay? On acids, on bases, and when it comes to salts. Of course, I'm tempted to do salts and show you solubility rules, whatever. But the things that you got to know about all these things, the acids and the bases and whatever. So let me quickly take you through. These are lists of words that you're going to meet. pH scale, indicator colors, neutralization, reactions of acids, naming salts, strong acid versus weak acid, concentrated versus dilute. What does it affect? H plus ions and OH minus ions. This is proton transfer in acids. Universal indicator, okay, H plus ions is here, then there's also proton transfer. Then you have indicators. Indicators, we talked about basic indicators. Then you're going to have an indicator called a universal indicator. Then you come to now oxides, okay? Oxides. And blah, 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 and you'll be done. So let's quickly go through this and master it. What we first went through when we were doing this topic, okay? Are you tired? You're not tired, right? You still have a bit of energy to just do a little bit more, right? What we first went through was that there are 3 important reactions you must know about acids. Acid plus metal. Acid, where is it? Here. Acid plus metal. Okay. Here, acid plus metal. Then acid plus base, the neutralization reaction. And then finally, acid plus metal carbonate. These are 3 important reactions that I needed you to know. 3 important reactions. Now, when you know these 3 important reactions, are you done with acids? No. There are more aspects now that we are continuing today. Okay? I'm not going to the reactions. We did them last time. Today we are continuing to further look at this acid. What was the last thing that I made you write, people? If you look at your books, what was the last thing that I made you write? Can you tell me what it was? What was it? It was? Or the table? Okay, it was the table of indicators. So I taught you indicators. Everybody? Okay. Thank you so much, Eric. So the last thing that I taught you was indicators. Let me go. So that means this is not the page where I taught this class. Let me go to it because I want to build it as a chapter. I want to show you important things that you must know so that you don't waste your time on things that don't come. Because that's the easy thing, to waste your time on things that don't come. Where was I writing? Was it on a white paper, on a blackboard, or a white one? Seems like I was writing on a whiteboard. Okay. Go to the other notebook here. Give me 1 second. Should be this one. No, this is bond energy. Okay, it's not a problem. I'll continue it as part 2 just here. Right. It's not a problem. I'm just continuing it as part 2. We just continue here. Right. What we are going to talk about is the next part. So let me tell you this. When you know the indicators, you must know the reactions of bases. So let me now say properties or chemical properties. Write with me to say the chemical properties of bases. Okay? You can say bases and alkalis, doesn't matter. When we say chemical properties, we want to know what reactions do they have. Okay? Chemical properties of bases and alkalis. Before we talk about the chemical properties, we can just give their properties, okay? General properties that you must know. What is a base? Remember, we are in chemistry, and we need to let's just do this very fast because this is small. This is for small stuff that we must know. We are in chemistry, and what we know is that we define things by giving their properties, how they behave. If you see something that can fly and land and fly like that, then it's a bird, and it has wings, and then it's a bird. That's how we define a bird. We don't say a bird is we just say a bird is an animal that can fly, do this. You describe the behaviors of it. So we are now going to understand bases by saying bases are chemicals with pH values above 7. So if you get any chemical which has a pH value that is above 7, then it's a base. Now, you can say, I'll highlight on important things, so we just need to keep going. A base which is soluble is known as an alkali. So an alkali is a soluble base. An alkali is a soluble base. Now what we know is that when we have these soluble bases, these alkalis, we know their colors, what they turn litmus. So I'm going to skip out. I'll write about it later when we say, right? But here you can say bases neutralize acids. In other words, when you take a base, you add it into an acid. The acid had a pH below 7. The acid had a pH below 7. If you add a base, how will you know it's a base? You will come and test the pH after adding the base, and you find the pH now being 7 or above 7 or exactly 7. Then you say, how did that happen? It shows that you added a substance which is called a base. So bases neutralize acids. Okay? Forming, yes, you can ask me, yes. Yes, you can ask me the question. I see the hand is up. You can ask the question, one dipper. I don't know why your mic is not audible. I can see you're talking, but I can't hear what you be saying. Like I can see when you unmute, but I can't hear what it is. You can send me as a text on WhatsApp. I'll see it right now. Okay, one dipper. For some reason, I can't hear you. What I'm giving you here is just general properties, easy stuff. But we know we have to know the reactions of bases. There's no running away there. We have to know the reactions of bases. Not only that, not only the reactions of bases, we actually now need to go on and talk even about oxides and about more things. So let's keep going, okay? We're not stopping here. What we would be saying is, now, we said, what did we say? We said bases neutralize acids. So when you add a base to an acid, you expect its pH value to change. And we said last time, or did I give you about this already? Bases are usually oxides. Okay, I want you to say here, metal oxides. Or metal hydroxides. These will be your bases. Metal oxides and metal hydroxide. Na2O, MgO. These are bases. NaOH. NaOH. MgOH. These are bases. Are we together? Now, we want to know bases in water. Before we talk about the two reactions of bases, bases in water, what they do is you put a base in water, okay, NaOH. Okay, example. NaOH, solid, okay, it dissolves in water, it becomes aqueous, right? So if it dissolves in water, what you end up getting is Na plus aqueous plus OH minus aqueous. This was the solid version, and it dissolved into water. And you can now say here, when alkalis, which is the soluble version of bases, when you alkalis are added to water, they form negative ions, which is OH minus ions. Okay? This one here, we know that when it gets into water, it will separate just like we did for an acid. But when an acid separated, one of the things we got was an H plus. And that's how we can identify it. For a base, it's going to release an OH minus in water. So bases release OH minus in water. Okay. Are we together? Right. This is more base in water. Now what you do is you keep going, okay? You're talking about bases in water. This is what happens. Now, the chemical reactions, okay? The second thing you must know is the two chemical of bases. The two chemical reactions of bases. Number one, Okay. Say, or instead of bases, you can say of alkalis. We like to use the word alkalis when we talk about. Right, number one, alkali plus ammonium salt. Ammonium salt. It is just something that has NH4. What? That's ammonium salt. So let's see what happens between your alkali and ammonium salt. You are going to get, okay, this gives you to get salt plus water. Oh, so it's like a neutralization reaction. Yes, but then it gives you the third thing, plus ammonia. Okay? So you get any salt plus water plus ammonia, which is NH3. So it's almost like a neutralization reaction. You get a salt and water. Huh? You get a salt and water. But you will get something else, which is ammonia gas. And remember, what is being neutralized here is not an acid. It's a base. How does that happen? NH4Cl reacts with NaOH. What do you get? So this is an ammonium salt because this is ammonium chloride. So this is an ammonium salt. What is going to happen here? Well, just like, so this is NH4Cl. Just like for acids, what we know is that this OH for acid, it was the H that was never going to go. The H for the acid never left. In here, it is the OH which will not leave. But what you're going to have is this Na will meet with this chlorine, metal and non-metal. We know how they like each other. Then you're going to have your NaCl. Then now you have OH, you get one H here, and it will be now H2O. Then this was NH4, it gave away one H to OH to make it H2O. It will now remain as NH3. You understand? Yes. And I want you to say, this is an example of what happens. And I want you to write down below and say, this reaction is used as a chemical test for the presence of the ammonium ion. Okay? For the presence of ammonium ion, the NH4+. So what you're going to do is you're going to have your solution. A solution which is alkaline. Because we know that an alkali, if it ever meets ammonium salt, it is going to be converted. It will no longer remain as a base or an alkali. So you are going to take your alkali, and we know that alkalis make everything be blue. So if you bring, let's say, a red litmus paper, it is going to be turned blue by your alkali. So you have a solution, a nice solution. you check your litmus paper, you see your litmus paper going blue, then you know, oh, this is my alkaline solution. Now what you're going to do, you bring something that you are not sure of. You don't know this chemical, number one, does it have ammonium in it? You just bring and throw it into the alkaline. Are we together? Okay. We should see that red litmus paper if we want to test. Yeah? Let me give you right now something which is important, because somebody once asked me, sir, can you help us prepare for, who was it? Who was it, sir? Is it Lehakwa? Who said, can you help us prepare for that paper? Can you help us prepare for the paper which is, what was it? Alternative to practical. LGK, are you around? Lehakwa? Lehakwa? Okay, he's not around. But he had asked me to say, sir, can you help us prepare for that paper? Now, I wanted to then teach you what we call test for gases, because this is going to be important, because what you're going to test for here is you're going to see, does ammonia gas get produced? Because what you know, everybody, listen, one of the things you must know, you should now know that if you take, everybody should know this, if you take any alkali and mix it with anything that has an ammonium ion, you must get ammonia. So this reaction is used to test for ammonium ion. If we get ammonia after adding that guy to a base, then we know he has an ammonium ion. So let's write this down. Alkali, like NaOH, is added to the unknown substance. You don't know, does it have NH4? You don't know. So you take your alkali, you add there. Okay? And gentle and gently, let me say, and gently warmed. Test for ammonia gas. Not the solution, you're no longer dipping. Test for ammonia gas using damp red litmus paper. I'll give you the gas tests. Okay? You test for ammonia gas. So you just mix these two and test for ammonia gas. Don't complicate it. Are we together? If ammonia gas is present, then the damp red litmus paper will turn blue. Okay? This would confirm the presence of an ammonium ion. If the NH4 plus is there, then it must react with any alkali to release ammonia gas. Okay? If we see ammonia gas being released, to say, oh, this thing had NH4. Because if it didn't have NH4, it was never going to react with your alkali to give you ammonia. All right. Now, let's keep moving. Reaction number 2 is just base plus acid. The one we did yesterday to give you salt plus water. Okay? Example? MgO plus H2SO4 to give us, this is an alkali or a base. This metal oxide, it means your acid, okay? This is your base. Then what do you get? You know what happens? This guy, which is not H, will come to Mg. So it becomes MgSO4. Then this O will go to H2. The hydrogens always remain alone. And there are two of them. They get O. This is what you have. This is salt. And this is water. And you're good. Are we together? So then when you know these two, then we'll clap hands for you and say, oh, you know the reactions of bases. Two of them. Are we fine here? Students, are we fine? Okay. Now, let's now come to here. Strong acid versus weak acid. Okay? When you're going to grow up, you're going to be told about the 7 strong acids. Then they'll tell you that every other acid which is not here is automatically a weak acid. Okay? So, here, what we know, let's write this. Let's just push for a few more minutes, just a few more minutes, like 10 more minutes or whatever. Okay? Acids are proton donors. Okay? Acids are proton donors. Why? They ionize, which means to separate in a solution, producing protons. What do they mean by protons? H plus ions. So here, H plus ions by producing protons. H plus ions. These H plus ions make the solution acidic. So this is the background. We want to see what then makes us say this is a strong acid. So the behavior of any acid, we know that acids, we know them by seeing some hydrogens there. All acids have a hydrogen. Now, when an acid goes into a solution, it will ionize. You should explain to people what to ionize means. It's to separate. Just like we showed you last time about an acid in water. E.g., we had H2SO4. Okay? It will separate to be H plus aqueous, 2 of them, plus SO4 2 minus aqueous. Can you see this? This is what we mean by dissociating or ionizing. It is to go into water and you split, you separate. All acids do this. Strong ones do that? Yes. Weak ones do that? Yes. So what is the difference between a strong one and a weak one? Let's now write. Strong acids completely ionize in water to produce a solution which has a very low pH. Which has a very low pH. Which means it is very acidic. Okay? So, when you talk about the strength of an acid, you are saying how much of the acid will split when you put it into water. If it's a strong acid, okay, here are the strong acids you know. HCl, H2SO4. These are strong acids. They completely ionize in water. Which means all the hydrogens that were in the acid will separate, all of them. On the other hand, skip a line and say, a weak acid. I don't want to see cats and dogs. I'm explaining to you the weak acid. So surely you're not forgetting this. A weak acid or weak acids, a weak acid will partially ionize in water. What does it mean? Not all of the hydrogens that were in the acid will separate. Ah, why? Why is it being stingy? Separate, man. No, it will refuse. Okay? And now, because of that, the pH of a weak acid in a solution will not be very low. It will be somewhere close to 7. 7 is a neutral value. So when the pH is close to 7, that's not a good thing. That's not a strong acid. Strong acids are far away from 7. They're very low pH values. So partially ionize in water and produce pH values which are closer to the middle of the pH scale. Okay, closer to the middle, closer to 7, closer to 7. That's the middle. Okay, closer to 7. Now, here is what you do. Here is how you represent it. Okay, weak acids are organic chem acids. So example of a weak acid is ethanoic acid, which is CH3COOH. Now, okay, if you take that guy and you want to show what happens to him in water, you don't put a single arrow. It's a weak acid, my friend. It's not going to fully separate, so it's not going to reach the end. If you put a single arrow, you're saying this reaction will reach the end. When that's a lie, only a little bit of the hydrogens in here are going to become H+. So this is going to be H+ plus CH3COO-. So yes, this hydrogen goes, but not many. Not many of them do that. So, wow, really? Yes. So that means most of this acid will remain as an acid even when it's in water? Yes. That's why it's weak. Okay? Are we together? Are we together? Now, let's go to another word which I need you to know. Okay? This was strong acid versus weak acid. Then now here, we want to say concentrated acid. Okay? I'm hitting important things here. Concentrated acid versus dilute acid. Concentrated acid versus dilute acid. So, is this the same as strong or weak? No! Strong or weak comes from what? How much of the acid actually separates in water? That's strong or weak. But for concentrated, we are saying when you take 1 liter of water, how much acid is in it? The more acid per liter, we say in chem per dm cubed, which means per liter, the more concentrated it is, whether it's weak or whether it's strong. Concentration has absolutely nothing to do with your strength. It has everything to do with the amount that is present. So, a concentrated solution. Oh, we have so much of the weak acid in here. Oh, we have so much of the strong acid in here, in this solution. What are we talking about? Concentration. Are we talking about its strength? Nothing to do with the strength. So a concentrated solution of an acid is one that contains, you don't have to know too much about weak bases and strong bases. Although they are there, you don't have to know about them right now. So that's why we're only focusing on the acid, because that's the syllabus. But as you keep going deeper in chem, you're going to see the strong bases and the weak bases. Okay. Right. Right? A concentrated solution of an acid is one that contains a high number. Whether you are strong or weak, that's not the subject right now. There is a high number of acid molecules per liter. So we say per dm cubed of solution. Oh, there's so much acid in here. This is a concentrated solution. But it has nothing to do with strong. Still, the weak acid will be concentrated, but still it won't dissociate completely. So, this does not always mean that the acid is strong. Though, as it may be made, this acid, it may be made from a weak acid. This solution could be very concentrated, but made from a weak acid, so it's still not strong. So I want you to say, when we talk about concentration, we are talking about the amount of acid per dm cubed of the solution. That is what we are looking at, okay? When we talk about the strength of an acid, we are talking about how much does it ionize in water. Does it fully ionize in water? If it does, fully ionize, which means fully separates into ions, then it's a strong acid. If it doesn't fully ionize or dissociate in water, then it is a weak acid. So, from a weak acid which does not dissociate or ionize, okay, should use them as you like, which does not dissociate. Which do not dissociate completely. Weak acid does not dissociate completely. So this has nothing to do with strong, okay? So, actually, listen to this interesting fact. A dilute solution of HCl, which is a strong acid, of HCl is more acidic than a concentrated solution of ethanoic acid, which is a weak acid. So, which one? Although the best case scenario, if you want a lot of acid, if you want acidity, would be to take a strong acid and make it concentrated. Oh, you now have a very acidic solution. But in the event that you don't, you would rather take a strong acid and make a dilute solution. It will form a strong acid solution, a stronger acid solution when you compare to you adding so much of a weak acid, because the weak acid will hardly separate. So you are going to need too much, way too much. But this strong acid will fully separate, so you don't need too much. No, you don't. Are we together? Students, are we together? Okay. Strong has nothing to do with concentrated. Separate those words. Do not speak jargon. Unbelievable, wrong things. We'll have a problem. Strength of an acid is how much does it ionize in water. Ionize means to separate. Weak acid. And remember to be able to represent them. Using, for a strong acid, your single arrow, separating fully. For a weak acid, equilibrium concentration solution here. It partially separates. All right. When you come next time we do the oxides, then we go to preparation of salts. We'll cover more of it on Saturday. As of now, I'm just going to put the links where you should put these notes that you have written so that I see, and you are dismissed. I'll send you an assignment that I'll design. Goodbye.